Now that we've discussed the actual process used and all the equipment, I'm going to go ahead and take this bow and I'm going to put it in the drawboard and draw it back. We have a stop on here to keep the bow from riding up the drawboard if possible. I just basically loop the Velcro over the riser and I fasten the Velcro on fairly loose. It's not meant to hold the riser in any particular position, just to keep the bow from rocking too much. The next step is to take your loop that you've tied and you put this through your D-loop. And then you just make a loop out of that. That goes through the scale, whether you're using this scale here or the X-Spot scale that we spoke about before. Now you'll just start to crank the winch just to kind of take up some of the tension. You're going to want to make sure as soon as you get some tension, not a lot, you just want to make sure that the bow comes up and seats against your stop. Once that's done, you'll just start drawing back very slowly. You don't need to rush this process. It's not a race. There is no prize for the winner. Now when you're drawing back, you want to make sure that you keep in mind your cam timing. You don't want to draw this back too far because you can severely damage your bow. So as I get the bow back to full draw, I'm watching my cam timing and I see that they're about to come in. It just drops over. I'm now at the back of the wall. I'll click in my safety right there. My bow is now properly placed in the drawboard and now I can start to take my measurements. Now our bow's at full draw in the drawboard and there's a couple quick measurements that you're going to be able to take and write down that are going to help you go from bow to bow, no matter what the axle to axle, brace height, poundage, any of that. This is going to allow you to make those bows feel like the exact same draw length. So what I'm going to do is I'm just going to take a bow square. We all have a bow square, or we should anyway. And we're just basically going to slide this in from the side. And we're going to use the side of the 4x4 as our flat surface. And I'll bring this down and I'll just line myself up on top. And I'll look down. I'll move this back and forth until it's just inside the knock, where the knot goes on the string. And I'm going to get about 28 1/8. Now I'll write that measurement down as my grip to throw to the knock measurement. The other measurement that's going to be very critical is the throw to the grip to the back of the D-loop. So I'll just slide this on back, line this up right quick, and I'm going to get 29 inches. That means that obviously from the throw to the knock to the back of my D-loop, it's going to be 7/8 of an inch. That's also going to be very critical when you go to replace your loop. So when you put on a new loop, you can put your bow in your drawboard, draw it back, and make sure that that loop is the exact same length. The other thing that we're going to do that's very, very critical is our peep to arrow. Now this distance here is the most crucial in helping you make one bow feel like the draw length's the same as the other. So I'm going to put an arrow in, and you're going to want to hold it from the top of the arrow, and you're just going to knock the arrow and then hold it on the arrow rest, but don't press down, because if you're using any sort of a spring rest or any rest that's susceptible to movement, it'll move down, and also you can flex the arrow and that'll change the measurement. So what we're going to do is we're just going to hold that. We're going to take our bow square, slide it down the top side of the peep until we touch the top of the arrow, and we got 4 inches. Now you're also going to write that down. And the reason that this is critical is if you go from a bow that's 31 inches to 35 inches, your draw length is obviously going to be different because of the axle to axle, dynamically speaking, from the throw to the grip to the knock or to the D-loop. And once you get those figured out to keep your form the same, a lot of people make the mistake of putting their peep height at the same height from the loop as they did on the shorter axle to axle bow. It's not going to work. You're going to have to make sure that the length you're looking at is the peep height to your arrow in determining that number. Now we've taken a few of the critical measurements off of the bow at full draw. I'm going to show you now how to safely let down your bow when you're done taking your measurements. You're always going to want to hold onto the handle when you do this, because while right now you're in your full let off position, it's only, from 11 to 15, 18 pounds depending on your current configuration. And while the handle being in the rear position will generally keep the bow at full draw, once we start to let up and the bow loads up, this handle won't do anymore, and then you're going to end up with a situation where the handle's out of control and that can be problematic. So we'll hold on to the handle, we'll pull off this safety here, and then we'll just start taking the drawboard slowly forward. You can see that the bow came out of the valley, loaded up, jumped back up to the 60, 70, whatever poundage bow you're shooting, and you'll just slowly let the bow down like so. The Velcro straps at this point are very, very helpful as it holds the bow from wobbling too much as you let down. Once you come all the way down, the bow will settle down onto the board, the strap will hold it, you get some slack down here, unhook your loop, your straps, and you're ready to go. Another handy trick that you can use a drawboard for is making sure that you're not getting excessive knock pinch at full draw. By excessive knock pinch, I'm talking about a knock point that is too stiff, or a D-loop that's too tight, or a combination of both. If you have a metal knock pinched on underneath with an eliminator button or any variation of those, you can be causing inaccuracy with too much knock pinch. So what you can do is you can either take just a knock, or here I have a gold tip pin bushing and pin knock. You can put them in your bow, draw them on your drawboard, and when you get to full draw, you're going to want to make sure that this bushing and pin is going in a direction of the rest. If you have excessive knock pinch, this is going to be pointing down or it's going to be pointing up. That's your indication visually that you have too tight of a knock. Now, you'll want to manipulate whatever system you're using, you're going to want to make sure that your system allows you the maximum accuracy by not having too much knock pinch. Now we've talked about some of the things that you can do with the drawboard, from checking your draw length from throw to the grip to the throw to the knock, throw to the grip to the D-loop, and the very important peep to arrow height. We also spoke about making sure that your system is going to be forgiving by not having too much excessive knock pinch. Now, you don't have to necessarily set up your drawboard with a scale like this. I always recommend it. I think it's a great tool for checking max draw weight, for checking holding weight, and a few other nifty things that you can do with it, but you don't necessarily have to do it, but I do always recommend it. So when you build your drawboard, don't be afraid to play around. Check all the measurements from axle to axle. You can check numerous things at full draw that you just simply can't do with your fingers. The other one is cam timing. There's a lot of debate about cam timing, and I've seen a lot of people check cam timing on a hook, or pull it back with their fingers, or even pull it back with a release. Now, some of those obviously can be done, and if you're in a field, you're not going to be packing around a 4x4 with a drawboard on it. But checking your cam timing with a drawboard is going to be the most accurate way that you can do it, because you're not using your fingers to twist a string, you're not doing any other inconsistencies. It's much more precise. You have a crank to minutely adjust that cam timing. So if you build your drawboard and you're not afraid to experiment, you're going to take your equipment to the next level.